Welcome to Tomorrow Unveiled, where we pull back the curtain on the most compelling breakthroughs shaping our future. When you hear extending life, what comes to mind? Often it's this vision of, well, radical, perhaps even fantastical immortality.
Right. Almost sci-fi.
Exactly.
Yeah.
But today, we're shifting gears to something far more immediate and, honestly, transformative. It's a goal that's truly revolutionizing longevity science, extending healthy, functional life, not just tacking on raw years.
Hmm.
This is the Immortality Update, and in this deep dive, we're exploring the week's most significant advancements in longevity science. Our journey is built on a really robust stack of sources articles, cutting-edge research papers, meticulous notes, all compiled by our dedicated research team.
Yeah. They've really pulled together the key stuff.
They have. This isn't just a news summary, it's a distillation of the most impactful insights, designed to give you, our listener, a true shortcut to being incredibly well-informed. Our mission is really to extract those vital nuggets of knowledge, helping you grasp what's truly significant and why it matters for all of us.
And if there's one overriding insight emerging from our sources this week, it's this fundamental paradigm shift we're talking about. The field is moving quite decisively, actually, away from the speculative pursuit of, just radically longer lifespans.
Right.
Instead, the focus is squarely on a pragmatic, almost engineering-driven mission. Health span extension.
Health span, that's the key term now.
Absolutely. It means pouring resources into interventions that preserve and restore biological function as we age, making sure that any added years are vibrant, productive years, free from the chronic diseases and frailty that have long been associated with getting older.
So if the old dream was simply adding years, the new reality is about adding life to those years.
Okay.
And the insights from our research stack this week seem to fundamentally shift how we think about that. What's the biggest takeaway you see from this reorientation toward functional life?
I think the biggest takeaway is that progress is now being measured by genuinely tangible advances, things that restore real function and vitality in people. It's no longer abstract. Our research team highlights new, specific metrics being used in actual human studies. Things like modified physical performance test scores.
Like how well someone can actually move.
Exactly. Or how far someone can walk in 6 minutes, their score on the clinical frailty scale. These aren't just numbers in a lab notebook. They're practical, measurable outcomes that show real-world improvements in how people move, think, and, live.
And this isn't just academic, is it? I mean, for you, the listener, what's the tangible difference this shift makes to your actual future? How does it affect the kind of research you should be excited about?
Oh, it's everything. It really is. It means the research isn't just chasing a number on a calendar anymore. It's about ensuring that you maintain your independence, your energy, your overall quality of life much, much later into your years. It's about empowering you to live better for longer through targeted interventions rather than just, hoping for more time.
That's a powerful distinction. Okay, so if extending healthy life is the goal, we really need to understand what speeds up aging in the first place. Our research this week highlighted a surprising new culprit, one that's definitely been on everyone's mind for the last few years: the long-term impact of COVID-19.
Yeah, this one was quite striking. The highly corroborated finding here is startling. Even a mild COVID-19 infection can significantly accelerate vascular aging.
Accelerate vascular aging, how much are we talking?
Well, studies are consistently showing it causes increased arterial stiffness, which is equivalent to approximately 5 years of vascular aging.
5 years from a mild infection. Just,
Without being
wow, let that sink in. That's truly startling. Does this mean everyone who's had COVID essentially just aged 5 years wise, or are there specific populations where this is more pronounced?
That's a good question. Our research indicates this effect is disproportionately severe in women and also in individuals experiencing persistent long COVID symptoms. So it isn't a universal 5-year jump for everyone, no.
Okay, that clarifies things.
But it is a strong signal for vulnerable groups. On the brighter side, though, our sources did find that vaccination against COVID-19 was associated with less arterial damage.
Ah, so there's a mitigation insight there.
Exactly. And the deeper meaning here, I think, is that long COVID symptoms aren't just some novel illness. They are, in many cases, a manifestation of accelerated aging, specifically in the vascular system.
That reframing is powerful.
It is, because it opens the door for geroscience-based interventions, what we often call geroprotectors, as potential therapeutic strategies. We could potentially address the root cause of these debilitating symptoms, rather than just managing individual issues one by one.
You know, when we talk about accelerated aging, it makes me wonder what other surprising connections scientists are finding. Our research team flagged something fascinating about a link between vascular health and the immune system. How exactly are those two intertwined?
This is a really remarkable connection, and it reveals a critical mechanism. It turns out poor vascular health, specifically restricted blood flow or ischemia, which is a common consequence of blocked arteries, atherosclerosis,
Right.
that actually sends signals to your bone marrow.
To the bone marrow. Oh,
Yes. And this causes a reprogramming of your hematopoietic stem cells. Those are essentially the master cells that produce all your blood and immune cells.
got it.
This reprogramming then favors the production of cells that suppress your immune system, often called foot soldier cells, from the myeloid lineage, while simultaneously reducing the crucial attack cells, the lymphoid lineage cells that fight tumors and viruses.
Wow. So bad circulation basically tells your body to make fewer defenders and more suppressors.
In a nutshell, yes. And the real-world consequence of this is quite stark. Our team highlighted a mouse model study where breast tumors grew at double the rate in animals that experienced ischemia.
Double the rate, just from poor blood flow nearby. Think about that. It's a stark reminder that what happens in your veins isn't just about heart health. It's fundamental to your body's entire defense system.
Absolutely. If we connect this to the bigger picture for you, it means maintaining your cardiovascular health isn't just good for your heart, which we all know. It's a direct investment in preserving a youthful and effective immune system.
Which impacts cancer risk, infection susceptibility.
Exactly. Throughout your life, it's really a foundational insight that connects these systems.
So we've seen how external factors like COVID can accelerate aging, and how internal systems like our vascular health impact immunity. But what if the very blueprint of our lives, our genes, has built-in trade-offs that influence how we age? That brings us to something fascinating called antagonistic pleiotropy. Did I get that right?
You did. Antagonistic pleiotropy. It's a classic theory in evolutionary biology, suggesting that genes beneficial early in life, particularly for reproduction, can actually become detrimental later on.
Okay, a trade-off.
Precisely. And what's truly compelling this week is the strong human evidence supporting it. Our research team highlighted a comprehensive human genetic study from the Buck Institute that found a clear genetic link between the timing of reproductive events, like puberty or first childbirth, and various aging-related outcomes later in life. It's some of the strongest human proof for this theory yet.
And specific examples are quite eye-opening, aren't they? Our research showed that girls experiencing menarche or their first period before age 11, or women having their first child before age 21, had double the risk of type 2 diabetes and heart failure later in life.
Double the risk. And even more strikingly, a fourfold increased risk of severe metabolic disorders.
Fourfold? That's huge.
It is. But conversely, genetic predispositions for later puberty and childbirth were associated with genuinely positive health span outcomes. Things like longer parental lifespan and even slower epigenetic aging. That's your biological age clock ticking slower than your chronological age.
So later seems better, genetically speaking, for long-term health. What are the mechanisms there?
Well, the key pathways involved here seem to be the body's master switches for growth and metabolism. Things like IGF-1, growth hormone, AMPK, mTOR signaling. These pathways are crucial for development early on.
Right.
But when they get dysregulated later in life, they can actually shift us from a growth and build phase into more of an aging and decline phase.
So what's the big takeaway for us from this genetic framework then? What does it tell us about intervention?
It provides a really powerful genetic lens for why metabolic health is so central to aging. It essentially reframes how many leading longevity drug candidates might actually work.
How so?
They're not just vague anti-aging drugs. They're potentially sophisticated agents designed to retune these core life history dials, these metabolic pathways, shifting the body's physiology towards long-term health and repair rather than just rapid early development and reproduction. It's like finding the genetic blueprint for intervention.
That's fascinating. Okay, let's pivot now and dive deeper into some of those cutting-edge interventions, because this is where the future of longevity really starts to come into focus. First up, the role of AI, artificial intelligence, as the co-scientist in longevity research. It seems clear that the sheer complexity of aging demands advanced tools. AI isn't just an assistant anymore, is it? It's becoming an indispensable partner.
Absolutely. A key insight emerging from our sources is that the new paradigm involves AI platforms acting as true co-scientists. They're not just analyzing data anymore.
Okay, so more than just number crunching.
Much more. They can model incredibly complex biology, generate novel hypotheses that human researchers might actually miss, and even design therapeutic candidates in silico that means entirely computationally before they ever go into a physical lab.
Which must dramatically increase efficiency and speed up discovery, right?
Hugely. And you can see this shift clearly in industry adoption. Our team noted that leading bio-AI firms, companies like Deep Origin, Rejuve.bio, Human Longevity, Inc., were major sponsors at the world's premier longevity biotechnology conference, ARDD 2025. That kind of high-profile presence is, well, it's clear proof of this fundamental shift in research strategy.
Any specific examples of what they can do?
Yeah, Deep Origin offers a fantastic example. They're pioneering what they call virtual cells to design and test therapeutics in a computational environment. Imagine they can effectively test drive potential drugs without the huge time and immense costs of traditional wet lab work.
Wow, like a flight simulator for drug discovery.
Kind of, yeah. So the impact on the field is just immense. This signifies a fundamental shift in R&D strategy toward a systems-level multi-omics approach.
Multi-omics, meaning looking at everything at once. Genes, proteins.
Exactly. Genes, proteins, metabolites, all the biological layers simultaneously. And that kind of holistic view is absolutely crucial for developing interventions that can actually address aging's multifaceted nature. It's too complex for just one target.
It really sounds like AI is becoming essential. Okay, a quick reminder for our listeners. If you're finding this insightful, please take a moment to like this video if you're on YouTube, subscribe to Tomorrow Unveiled, and definitely turn on notifications so you never miss an update on the future.
And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners.
It really does. Thanks, everyone. Now, let's talk about regenerative medicine's new frontier. Our research flagged something being called skin in a syringe. That sounds intriguing. What is it?
It is intriguing. It's a genuinely groundbreaking technology. Essentially, it's an injectable and 3D bioprintable hydrogel designed to regenerate fully functional dermis. That's the deeper layer of skin for scar-free healing.
Scar-free. That's a big claim compared to traditional grafts.
It is, because this is a significant leap beyond traditional skin grafts, which, as you know, often lead to scarring and a loss of function. No hair follicles, no sweat glands.
Right, it's more like a patch.
Exactly. The aim here is different. It's to reconstruct living, functional tissue. And what's truly foundational about this platform, according to our sources, is that it appears to solve the vascularization problem for engineered tissues.
Getting blood vessels to grow into it, that's always been the hurdle.
The major hurdle for so long in regenerative medicine. Solving that, how to get blood vessels to grow into the new material and keep it alive, is huge.
And that solved problem must have broader implications, right? Extending well beyond just skin.
Absolutely. It's seen as a foundational platform with potential for regenerating much more complex organs. Things like liver patches, maybe pancreatic islets for diabetes. It's really paving the way for the future of organ repair, potentially.
Very exciting stuff. Okay, moving into clinical progress now. Our research team highlighted the initiation of a phase 1 clinical trial for something called BGE-102. What's this one targeting?
Right, BGE-102. This is a novel, orally available, so a pill, and importantly, brain-penetrant inhibitor targeting something called the NLRP3 inflammasome.
Okay, NLRP3 inflammasome. Break that down for us.
So the mechanism here is key. NLRP3 is understood to be a major driver of inflammaging.
Inflammaging, that chronic low-grade inflammation we hear so much about.
Exactly. That simmering background inflammation that quietly contributes to a huge range of age-related diseases, everything from Alzheimer's to heart disease to arthritis.
So targeting NLRP3 gets at a really fundamental process.
Precisely. This clinical trial is considered a landmark direct clinical test of a core geroscience hypothesis. It's directly targeting a fundamental aging mechanism that seems to underlie so many different age-related conditions. This trial will definitely be closely watched by everyone in the field.
Makes sense. Now let's touch on some other promising preventative approaches that are maybe still in preclinical stages. What else did the research team find?
Well, one interesting finding was about a drug called blarcamazine. In preclinical studies, so animal models, it apparently entirely prevented cognitive decline and oxidative injury in an Alzheimer's animal model.
Prevented it entirely.
How? By enhancing the cell's natural waste clearance process, something called autophagy. It helps cells clean out the junk. And this really highlights a potential shift towards prophylactic or preventative strategies, the idea of treating before symptoms even appear.
Treating before the disease starts, that's a big shift.
It is. We're also seeing exciting work on FOXO proteins, specifically FOXO1 and FOXO3. They've been identified as promising therapeutic targets for maintaining cartilage integrity and potentially mitigating osteoarthritis progression.
Okay, so joints as well.
Right. And another interesting area is cellular quality control. There was a discovery that improving the fidelity of protein synthesis, basically making sure proteins are made correctly, can extend lifespan in model organisms through a mechanism involving something called Pleiotropy. It really points to keeping the cell's internal machinery running perfectly as a longevity target.
It all comes down to quality control at the cellular level, it seems.
In many ways, yes.
And it's also important to remember, isn't it, that some of the most powerful geroprotectors are already at our fingertips, and they don't require a prescription.
Absolutely. Our sources consistently remind us that even structured physical activity is an incredibly powerful tool. Studies have shown it can lower biological or epigenetic age by approximately 2 years in just 8 weeks for previously sedentary middle-aged women.
2 years younger biologically in 2 months. That's impressive.
It really is. So you should never underestimate the power of a good workout.
Definitely noted. Okay, as exciting as all these scientific breakthroughs are, we absolutely must also carefully consider the ethical and practical path forward. And one of the biggest challenges, as highlighted consistently by our research team, is the equity and accessibility dilemma.
Yes, this comes up again and again. Our sources indicate that advanced resource-intensive therapies like that skin in a syringe we talked about, well, they're likely to be incredibly expensive, at least in the early stages.
Which raises a critical ethical concern.
A huge one. The research team refers to it as the longevity divide. Without proactive intervention, these breakthroughs could easily become luxury commodities, primarily available to the wealthy.
And that would just exacerbate existing health disparities worldwide.
Massively. The imperative then seems clear. We need careful thought around policies and global collaborations to ensure equitable access. We have to prevent a future where your healthy lifespan is determined primarily by your socioeconomic status. It's about making sure everyone could potentially benefit from these advancements, not just a privileged few.
That's crucial. And this also raises an important question regarding predictive aging and its societal impact, doesn't it? Thinking back to those fascinating genetic findings on puberty timing and disease risk, there's potential for misinterpretation there.
There really is. This kind of knowledge could inadvertently lead to a sense of genetic determinism, where individuals feel their health trajectory is sort of fixed from birth. Or it could lead to health anxiety, even stigmatization of certain groups.
Right. You don't want people thinking, oh, I have the bad gene, there's nothing I can do.
Exactly. That's why the ethical framing is so critical. Our research emphasizes that scientists and communicators, people like us, must frame this knowledge as a tool for empowerment. We need to focus on the modifiable risk factors, like body mass index was mentioned in that study, and focus on preventative public health strategies.
So it's about providing actionable insights, not delivering fixed destinies.
Precisely. It shouldn't be about creating new at-risk categories based on unchangeable genetic predispositions.
And finally, there's the critical issue of safety and the ethics of prevention. Our sources reinforce that the bar for safety has to be exceptionally high for longevity therapies, doesn't it? Especially since they're intended for long-term use in individuals who aren't actually sick yet.
Extremely high. The decision to intervene preventatively in otherwise healthy people is a profound one, ethically and medically.
That blarcamazine example for Alzheimer's prevention really illustrates this complex ethical frontier. Treating healthy individuals who are just at high risk for a future disease, what does that require?
Well, it demands exceptional certainty about the benefits outweighing any potential risks. It requires highly accurate biomarkers to even identify the right candidates reliably. And of course, incredibly robust informed consent processes. It's truly a new frontier in medicine with complex ethical considerations.
And related to safety, a word of caution also emerged from our sources regarding some things already being tried.
Yes, specifically interventions like rapamycin. While it shows promise in animal models, the consensus highlighted in our research is that it currently lacks clear human efficacy data for longevity, and it definitely carries potential risks.
So the message is caution against off-label or DIY use.
Absolutely. Extreme caution is urged until rigorous clinical trials confirm both safety and benefits specifically for longevity in humans. The science must lead the way, not hype or hope.
That's a vital point. Okay, so to synthesize our key takeaways from this exploration within Tomorrow Unveiled, we've definitely witnessed a profound reorientation in longevity science, haven't we? A shift from merely extending lifespan to a dedicated focus on extending health span.
Yeah, that's the core shift.
And this movement is being propelled by, well, the identification of surprising systemic aging drivers like we discussed with COVID and vascular health, the indispensable role of AI acting as a co-scientist, and the incredible promise of new interventions across regenerative medicine and targeted pharmacology.
And all of this balanced, as it must be, with those critical ethical considerations for how we equitably apply this burgeoning knowledge.
It truly is an unprecedented toolkit emerging. The convergence of regenerative medicine, advanced systems biology, and artificial intelligence is creating this powerful new set of capabilities to systematically deconstruct and hopefully address aging at its very roots.
It feels like we're moving from observation to engineering in many ways.
That's a great way to put it, and we can anticipate several key milestones on the horizon, can't we? We expect to see more preclinical findings like that skin in a syringe hopefully progress to clinical translation.
Definitely. We'll also be closely watching for upcoming data readouts from important trials like the BGE-102 inflammasome inhibitor.
And we're likely on the cusp of seeing the emergence of entirely new drug candidates that were actually discovered and designed by those AI platforms we talk about. The pace of innovation just feels like it's accelerating.
It certainly does.
So this deep dive really shows we're actively engineering a future of extended health span. Now, we love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about the Immortality update and these developments.
Yeah, we're really curious to hear your perspectives.
And maybe a final provocative thought for you to reflect on. If we do succeed in significantly extending the period of human vitality, what new societal and philosophical questions might we, as a global community, need to grapple with? Questions beyond the purely scientific to ensure this future truly benefits all. That's something for all of us to consider as Tomorrow Unveiled continues to unfold.